So this is about specific heat capacity using the applet, and the particular one that I chose is on a timer, so I have to work relatively fast on this one. Of course, makes sense, they want to sell their product. So here we go. I'm gonna only do copper and lead. I'm gonna start out with copper. I'm gonna try to use the largest mass possible, 200 grams in this case, and the high temperature. So I'm going to go from hot specimen to cold water first. So I'm going to choose the lowest possible temperature for the water and the smallest amount of mass, 200 grams. I wish this would be actually smaller. The less water, the better. The more metal, the better, because of the large difference in specific heat capacity. So I'm going to hit the play button here, which means now the temperature between the two is adjusting, and we can already see that the final temperature, as the heat is flowing out of the hot copper into the colder water, the final temperature is going to be 22.03 degrees Celsius. I'm simply going to call this 22. All right, going to stay with copper, but this time around I'm going to start off with cold temperature, so 0, and high temperature for water, 60. I wish that would be higher, but oh well. Here we go. And again, they are adjusting, so the final temperature, the mixing temperature, is pretty much 55 degrees Celsius. Okay, then going to switch over to lead. There we go. So again, highest possible temperature, and then water, lowest possible temperature. Hit play button here, and we can see that the temperature that we get is 16 degrees Celsius. Yesterday I measured 17.5. I wonder, I'm going to do that again. It's interesting. Lead has a much lower specific heat capacity as compared to water anyway, but to copper, and that's why that mixing temperature is much closer to the water temperature. All right, and the last one. I put both in there. That's what happened. I have to unclick the copper. There we go. All right, third time's a charm. All right, as I said yesterday, I measured 17 degrees Celsius. Oh, all right, okay. So yeah, 17.5 is I had measured. I had recorded this already. And then we do lead with the lowest possible temperature, and here the water with the highest, and 58.25 degrees Celsius. All right, I'm actually done with that, so I'm gonna analyze the data. Now I have time. So these are the data that I recorded yesterday, and I just made sure that I got them again today. Now I'm not on a timer anymore. So here I'm going to multiply. First I'm going to calculate the difference in temperature. So 55 minus 0 is 55. 55 minus 60 is -5. Let's see, this one is 58.25. That's how much the lead has increased in temperature. And then this one is -1.75. That's how much the water has decreased in temperature. And I wish it wouldn't do that. Let's see, and then on the other one, so 78, and here the heat is flowing out of the copper, so it's a -78, into the water, so that's a +7, flowing out of the lead, so that's -82.5, and then this one is 2.5. And then I'm going to calculate temperature difference times mass times heat capacity. So let's see, -78 times 200 times the specific heat capacity for copper. I looked it up, 385 joules per kilogram in Celsius degrees. And because the heat capacity is given in kilograms, but the mass is given in grams, one of them has to be converted. So I'm dividing the mass by the grams here by 1,000, get into kilograms, and then I will have a nice joules there. So negative 6,000 rounded, pretty much looks like two significant figures. Okay, now the water, 7 times 200 times 4186, divide by 1,000, enter, there we go, rounded 5,900, so negative 6,000, positive 5,900, so the same amount of heat that flows out of the copper should flow into the water, but of course there are some measurement errors here. In fact, in this case, the measurement errors are 6,000. I divide the larger number by the smaller one and ignore the negative in this case. And I also ignore the one in the front. The one in the front simply means 100%. So 6,000 is 1.6% larger than 5,900, or around 2%. In this applet here, I expect that I come up with really small errors. You will see that in the actual experiment, you come up with really large errors. All right, gonna do the lead. Hold on. There we go. So negative 82.5. This one here needs to be switched to 128. Oops. I could have typed that already. There we go. So negative 2,100, and then the water. There we go. And that is a 2.5 in the front. And that also looks like 2,100. There we go. So there we go. And, 0% error, obviously. If you divide the two numbers, you come up with 1.00. And again, you ignore the one in the front, and you have a 0% there. Okay, this one, there it is. There's the other one. So, again, the copper here. Let's start with the lead. Let's see, 58.25 times 200 times 128 divided by 1,000, so negative 1,500, and then the water, and that is a negative 1.75. Oh yeah, the other one was positive, by the way. Forgot to take the negative out. So let's see, negative 1.75. It's lead, right? Enter both of them 1,500 rounded. And as I said on the first one, I forgot to take the negative out, so it is positive. And then again, 0% error on this one. And then finally here for the cold copper. So there it is. And that one is a 55. Need to change this one back to 385. So rounded negative, again it's a positive actually, 4,200. I keep forgetting to take that out. So here's the water, and that one is negative 5 degrees. And also 4,200. So this applet here shows us that the amount of heat flowing out of the hot part, may that be the metal or the water, flowing into the other one, may that be the metal or the water, means that that amount of heat is the same. In a real experiment, that should be the case as well. But then, of course, in this real experiment, you actually have a lot of measurement errors. So don't expect, or actually expect quite large errors when you're doing this one. 20, 30, 40% even. All right, so that's this particular applet.